Welcome to solverfy.
So we find the distance to the image using equation 23-8, which says, and this is part A here, that 1 over the distance to the object plus 1 over the distance to the image is equal to 1 over the focal length. Therefore, the distance to the image, d sub I, is equal to distance to the object multiplied by the focal length divided by distance to the object minus the focal length. So for part A, the distance to the object is 10 meters, and we're going to multiply that by the distance, or the focal length, which is 0.105 meters. So both meters I'm just going to pull outside. Meters times meters gives meters squared. So you have meters squared on top, divided by 10 minus 0.105. Both have units of meters, so I just pulled the meters outside here. So carrying out this expression, we find that this distance is 0.106 meters, which would be 106 millimeters, but we'll just leave it in units of meters and box that in as our solution for part A. Now for part B, all we're asked to do is, using the same focal length, change the distance to the object. So now for part B, the distance to the object is no longer 10 meters, but 3 meters. And we multiply that by our same focal length, 0.105 meters, divided by, this time, 3 minus 0.105. And of course, we know that this entire expression is going to end up giving us units of meters, so we'll just write units of meters outside here. So carrying out this operation, we find that this is equal to 0.109 and then the units here are meters. We can go ahead and box that in as a solution for part B. Part C wants us again to do the exact same thing, but once again change the distance to the object. So the distance to the image here is going to be equal to, this time the distance to the object is 1 meter, so it's going to be 1 multiplied by the focal length, which is again 0.105 meters, divided by 1 minus 0.105. And all of this is going to give us units of meters. So carrying out this operation, we find that for part C, the distance to the image is 0.117 meters. And we can go ahead and box that in as our solution for part C. Now part D has asked us to find the smallest object distance from the maximum image distance. So we're just going to swap the object and image here. So this is going to be D0 minimum. So we'll just write min, which is going to be equal to the distance to the image maximum, which we're told is 0.132 meters. And again, we have the same focal length, so this is going to be multiplied by 0.105 meters. And then on the bottom, you're going to have the same thing, where it's 0.132 minus the focal length, which is 0.105. And this entire expression is going to give us units of meters. So we carry out this operation and we find that the minimum object distance here would be 0.513 meters. And we can go ahead and box that in as our solution for part D.